people, which is a pleasure to stay with us here. Excuses from our director. He must to move very quickly to the mayor to have a meeting with the politics. Nothing to say. And he asked me to present in few words the institute. No, the Institute of Marine Science in Barcelona belongs to High Council of Scientific Research in Madrid, in Spain. Is the major center of marine research in Spain as well. You have more or less almost 300 people working in this building. You develop practically all lines of research in marine science, from marine geology, marine biology, ecology, natural resources, physics, chemicals, project. You have 14 groups of research, and it's an honor for us to say one of the center's leaders in all these aspects in the Mediterranean. This means that it's nice to say that, no? But the more important now is to thank all of you to be here, and also I would like to know our project, your project, to institutions, association, and it's also a pleasure to have again Eva with us. She was with us during several times. You work in the Department of Marine Resources. They know much better than me, perhaps, some of the people in our group in the Institute, and she can present yourself. And also for me, it's a pleasure to present herself. Thanks a lot. And any information that you need about the Institute, don't hesitate to contact with me or with the director, and also with Eva. No? I give you some information about the Institute now, but now it's a pleasure to be here in a very nice city in the Mediterranean, and you have a good extension also in the city and the Institute. Thanks a lot. Huh?
It's a pleasure to be back here. It's very strange to be here speaking in English, actually, looking at my colleagues. But it's really nice to be back. It's brought a lot of memories, and it's really, really nice. I guess I don't have a lot to say. I worked here for several years, and it was really good until the crisis kicked us out, me and my family, and we ended up in Norway, which was actually really nice. We were very welcome, and for the last 3 years already, I think, even going to more, I've been working in an organization called REV Ocean, and we have almost the whole team here. There's a couple of people that are now with the submarine, and a couple that couldn't make it to Barcelona in this trip. But most of the team is here sitting with us. And Nina, you're going to give the presentation? Mm-hmm. So Nina Jensen, who is the CEO of REV Ocean, will give a presentation about REV Ocean. And the idea was a bit that we can then have a discussion on anything that you want to ask or to discuss with us, potential future ideas to work together. That's we're here until I think we have an hour. So there is no rush after Nina has finished her presentation. And I don't know, should I present the whole team one by one? So Nina Jensen is the CEO, and I may get your titles wrong, but correct me. Or your surname, sorry. Øystein Mikkelborg is the Director for Marine Operations, Alex Rogers, Director for Science. Trond, don't ask me to say your surname. Can you say what your exact title is?
Chief Engineer.
Chief Engineer. Maybe all these will make more sense when Nina has presented the company. Irene is financial... Certified accountant. Oge is, I don't know exactly the title, but it's leading the whole operation of building the vessel. Niels is one of the captains. Sarah Fraser is leading the charter side. Tamara is our sustainability manager. Ellen is the other one of the captains. And Susanne is financial something else as well. And I'm the science coordinator, working with the whole team, but directly with Alex. So maybe I'll let Nina give the presentation, and all these roles will make more sense in a moment.
Thank you, Eva, and I'm also very appreciative that we were allowed to steal Eva from you to come work for us in REV Ocean. So thank you so much for that, and of course thank you for inviting us here to visit with you today and share a little bit about REV Ocean. Please feel free to stop me at any point if you have questions, and we'll also have ample time towards the end if there are things that you are wondering about. I like to start all of my presentations by saying a little bit about the ocean, and of course I don't really need to explain this to you, but nothing is more important than the ocean. And actually all life on this planet originated in the ocean. It's estimated that life started in the ocean more than 4 billion years ago, which is 7 times longer than life on land. And as my fisheries biologist professor at the university would say, humans are nothing but a poorly evolved fish. Obviously, marine biologists and fisheries biologists in particular have a fancy for fish, but no doubt they are important, and we know far too little about them and their environment. And of course, the ocean provides us with a lot of services that we simply could not live without. They provide us with more than 50% of the oxygen that we breathe, maybe as much as 80%. It regulates our climate and actually contains more than 20 times the amount of carbon on land. And of course, it's also a very essential food source for billions of people all over the world. So it's quite surprising to see the way that we are currently treating the ocean. Because in our lifetime, in more than 40 years, we've lost more than 40% of life in the ocean. And unfortunately, the situation is escalating as a result of climate change, plastic pollution, and overfishing. And this is the reason why the REV Ocean initiative was started up. It's an initiative initiated by Norwegian billionaire Kjell Inge Røkke. And his background is as a fisherman. That's where he started his career. And he's also since then moved into producing energy from the ocean, predominantly from oil and gas, but now increasingly from renewable energy. And he, throughout his career, and of course now over the past decade or so, he's become increasingly concerned about what is happening in the ocean. And he has actually calculated the amount of hours that he probably has left in his lifetime and how he wants to spend that time. And he decided that he wanted to pay it back to the ocean and make a real difference and try to actually restore the health of the ocean. So that is the essence of the REV Ocean initiative, to create one healthy ocean. And to do that, we are currently building the world's largest and most advanced research and expedition vessel. She will be 183 meters in length and will be offered as a free platform to scientists, yourselves, and others from all over the world to come on board and uncover the knowledge gaps of the ocean, find solutions to the wicked problems that the ocean is facing, and of course make sure that we protect and preserve the ocean to a much greater extent than what we're doing today. And the vessel is quite unique. I don't know how much you've looked into it already, but the vessel is scheduled to operate all over the world in all sorts of conditions. It's Polar Code certified, so even though it's not an icebreaker per se, she can operate in icy conditions. We have a lot of exciting equipment on board, and when we were deciding on how to both design the vessel but also what equipment to include on board, we had a consultation process with the major scientific institutions, and they were able to provide a list of the different types of equipment that they were currently lacking in their work, or that they wished were on board a research vessel. And we took the entire list from all of the scientists and we packed it into the REV Ocean vessel. So with the equipment that we have, we're able to do sampling down to 6,000 meters. The various types of equipment can be launched both through a moon pool in the center of the vessel, but also over the side using cranes. The vessel can hold up to 55 scientists at the same time, and also have quite an extensive number of both laboratories, a large auditorium, abilities for live streaming, both from the vessel itself, but hopefully also from some of the other equipment that we have, such as the submarine. And of course, in addition to the science, we'll have facilities to host workshops, convenings, various types of meetings, and of course, education for kids and youth. The ship will be operating in 3 different modes. The most important one is, of course, the science mode, and since we have both Alex and Eva here, maybe you want to say a few words about the science program and the selection process, but we can get back to that towards the end. But in addition, it will be operating in what we call ideas mode, which is on various types of expeditions to spark innovation, new ideas, and exploration when it comes to the ocean, whether it's finding new shipwrecks, new species, or inviting key stakeholders from all over the world to come on board the vessel and really advance ocean solutions. And the final operating mode of the vessel is what we call charter mode, and where Sarah is our key expert. And the aim of this is to rent the vessel out to key individuals from all over the world and cover some of the operational cost of the vessel. Operating something like this is, of course, quite expensive, and given that it's free for all the participants that come on board, trying to find a way to cover some of those expenses is the prime focus of chartering the vessel out. And of course, the vessel, as a result of that, holds quite a high standard. It is in many ways 4 ships in one. It's a research vessel, it's an expedition vessel, it's a trawler, but it's also a super yacht. So we like to say that it's like James Bond meets science. It has very high standards and, of course, excellent facilities that charter guests would expect when they're chartering a vessel of this kind. And of course, the bonus that we're hoping to also get out of this is to spark more interest and global philanthropy, so that more money is being channeled into both ocean science and, of course, supporting the solutions to restore the ocean back to health. So I said that we can at any given time invite approximately 55 scientists on board, but of course we want to engage a much larger community than those that can be on the vessel at any given time. So we've been working with a gaming company to also develop an interactive system where people from all over the world can virtually come on board the vessel and explore all its different facilities, meet the scientists when we are in operation, and get all sorts of environmental data about the scientific research that's being undertaken, discoveries that are being made, the operating conditions and where the ship is at, our fuel consumption, waste being generated on board, the weather conditions, and so forth. So it's a very interactive platform that will hopefully also spark the interest of kids and youth all over the world to become part of the journey together with us. There are, of course, a number of issues that we could be covering, and there's still so much that we don't know about the ocean. But given that we want to restore and fix the major problems of the ocean, we did a mapping exercise of what we think are the biggest problems that needs to be resolved. And that these three are the ones that we've chosen as our focal areas. So climate change and ocean acidification, plastic pollution, and overfishing. And even though probably climate change and plastic pollution are the ones that are growing most rapidly, overfishing does remain the biggest single threat to the ocean still. And we've decided that there are three important things if we want to save life in the ocean. Of course, we need to improve our knowledge and understanding. Currently, the estimate is that we've mapped and explored about 20% of the ocean, which means that more than 80% still remains to be discovered and explored. And of course, it's virtually impossible to manage well what you don't know. So making sure that we have all the right knowledge and understanding the ocean and the different processes better is key to restoring the health of the ocean and managing it better for the future. Then, of course, importantly, is to make that knowledge more readily available. There's already a lot of scientific reports and data out there, but making that more accessible, both to the scientific community, but also to decision makers from all over the world, is critical because what good does the knowledge do if it's not being put to good use or even blatantly ignored when key decisions are being made? And then finally, of course, turning the knowledge that we have and the knowledge that we're gaining into concrete solutions. So the ship will also be used as a dedicated testing platform for different types of technology, and also to hold policy convenings, as an example, to really advance solutions. And of course, when inviting different types of innovators and technology experts to come out with us, we also want to provide matchmaking services so that they can get access to funding and investors from all over the world that would be willing to invest in the different projects that are being piloted. So we have some quite exciting scientific equipment on board, and I'm wondering, maybe Eva, if I should invite you up to do the next couple of slides. This is about the ROV and, of course, the Hakon cruise that we recently went on, if you like.
Sure. I don't know if I'm the best here in the ocean. Alex or Øystein will know more, but I'm happy to do this. I think I look there without glasses. So this is the ROV. So this is a new ROV that was finished last year, 2 years ago. And we used it for the first time in a project that we had in September, October. We took the ROV to the Arctic, straight away from the factory to diving under ice at very great depths of 4,000 meters. But it's a really great beast. It's the ROV and it has the TMS, which is the tether management system, which you cannot see. Oh, you can see it here, I think. Here it has, so the TMS, I think the Liropus has the same, I think, right? So you have the TMS, the ROV and the TMS on top, where you have an additional, in this case, 1,000 meters of tether. So it comes down with the TMS all the way to the depth you want to work, and then it attaches, and you have, in this case, 1,000 meters where the ROV can be working and is not being pulled by the cable directly. She can go down to 6,000 meters depth and has an amazing set of science kit with the ability to sample for almost everything you can think of. Of course, can sample with the articulated arms. It has a suction sampler with 8 chambers that are on the back, which I don't think here. There you can see here. You can push core with the ROV, and it has very high definition cameras as well. So I don't know what's it's here. So in September and October last year. She was ready to go, and we had the possibility to bring her on the Kronprins Haakon, this is the Norwegian icebreaker, to take her to go and explore for hydrothermal vents in the Arctic on the ice. And this had never been done before. The vents had actually been located in 2014 by a team from AVI and from Woods Hole. But they didn't have an ROV, because usually you don't dive with ROVs under ice at these depths, particularly in the rough terrain like hydrothermal vents. But this could be done, so we said, well, let's do it. And the ROV is called Aurora, was taken from the factory straight into the vessel. We did some shallow water tests first for, I don't know, a few hours, and went to a deep place, did another test there, which went well after a while, but we did have the ROV on the seafloor for a few hours where we were all having a panic and heart attack, but they managed to get her back. And from there we went straight in the ice. And 2 days later we were diving for the first time on hydrothermal vents. You have another one. So yes, so we went from Norway, from Tromsø actually, so we flew into, the team flew into Svalbard, and then we to the Kronprins Haakon. So you have Norway here, Greenland here, and this is the Gakel Ridge in the Arctic Basin, and this is where the Aurora vent field is. And we knew where it was, so we didn't have to go looking for it, but it's an area covered with permanent ice, and so it's actually quite hard to work there. You can't go where you want to go and work, and this vent field is quite small. It's only about 100 meters in total, the active area. And you have these huge ice floes that are just moving all the time, drifting, and they're pushing you, and you can't, the icebreaker, the Kronprins Haakon cannot break. It's not a nuclear icebreaker like the Russians. You cannot break through any ice. So you have to go a bit with the flow and find the open leads, and then position the vessel in the right position, hope the drift will not change speed or direction, and let the vessel drift towards the vent, deploy the ROV in time for it to go down to 4,000 meters depth, move towards the vent, work as much as you can while the vessel is drifting over you, and then recover the ROV and come back. So we managed to do that 7 times, so we had 7 successful dives. I was one of the cruise leads. It's my project, so I was one of the cruise leads. And the first dive, and the first 3 dives, I think, we planned them as that's the only dive we're going to have. So we needed samples for geology, for geochemistry, fluids from the vents, microbiology, and biology, and we had to do all in one go. And then we ended up having 7 dives. So in the end, it was like, yeah, let's have another one tomorrow. But we managed to go there, map the whole site, which was quite amazing. We found 3 black smokers, active black smokers. Can't really see them, but they're really beautiful. They're not very big, but they were really, there was a lot of activity going on. Not a lot of fauna like you used to see in the Pacific, where you have all the giant tube worms and the mussels, and in the Atlantic you have the shrimp. But you can see the little white dots in the hands to the vent, which is that one over there. Those are amphipods, the bigger dots. And the tiny dots, which you can maybe see, well, you can't really see them, those are gastropods. We had a species of limpet that is being analyzed now. It's in a cuculinids, in the family of the cuculinids, and the interesting thing is that the only other cuculinids are known are from Antarctica, from caldera in Antarctica. So that's quite interesting. We'll see, they're being analyzed now, so we don't know what species it is yet, and how close it is linked to that species from Antarctica. And then the amphipods, and not much more apart from the bacteria. And I think that's it. Maybe someone else wants to talk about stuff.
And of course, this is the reason why we are in Barcelona at the moment. It's to launch the submarine, which will be the world's deepest diving hulled submersible. It can take 3 people down to 2,300 meters in depth, and of course provides unprecedented views and experiences for those on board to first-hand experience the great depths of the ocean. And of course this is also an addition to the science equipment on board the vessel, but we also see this as a really important component for communication and outreach, to really create more awareness about what is going on in the ocean, but also enthusiasm and interest in protecting, particularly the deep ocean. So the sub is equipped with a lot of heavy documentary filmmaking equipment, in addition to the scientific manipulator arms and sampling equipment. And we are crossing our fingers at the moment that the sub will be ready for launching tomorrow. There are still some final details to be worked out, but looks like everything is going okay. And then after the launch tomorrow, she will be going on the first expedition. Øystein, when? Later this year.
Later this summer.
Later this summer, yeah. And in the Med. So, so that will be exciting. And this is what it looks like at the moment. I think this photo was taken earlier today. So some of our team members are still there with Triton to make the final adjustments to the equipment. And of course, we are quite impatient in terms of the main ship being ready. It was supposed to be in operation from May last year, but it's been significantly delayed due to a series of unfortunate events, to say the least. So now the best estimate is that it will be ready in 2 to 3 years' time. But of course, that's why it's really important for us to make sure that we can use both the sub and the ROV together with other science partners and on board other research vessels. So both of these pieces of equipment will be deployed and put to good use together with our team over the next couple of years until the vessel is ready. But of course, the ocean can't wait. The situation is serious, as I mentioned initially, and we really need all hands on deck in terms of developing the solutions. So we are also working on a number of initiatives already to that end. So together with a number of different partners, we are working to scale up dedicated solutions to solve the plastic pollution in the ocean. One example is collaboration together with a company called Pinovo, who have a very specialized technology to collect paint, plastics from paint. Actually, microplastics leakage from paint has, in a recent report, been documented to be the single largest source of microplastics in the ocean. The solution is relatively easy. You know, when you're doing maintenance of bridges, oil platforms, and so forth, you just make sure to collect it using a specialized vacuum hose. This is now being implemented on board the different platforms, oil platforms in the Aker system, as a direct result of our collaboration. So that's just one of many examples of how we are working with partners to scale existing solutions. And it's not always a matter of finding new knowledge or finding new solutions. It's also a matter of making what is already out there work and get it financed. We've also been working on a number of different seaweed initiatives. Of course, seaweed is a really important solution both for climate change and for biodiversity. So we've been hosting several workshops to that end with leading experts from all over the world. We are exploring with different companies how seaweed could be planted on a large scale in connection with existing facilities in the ocean, whether it's oil platforms or new offshore wind installations, and also looking into how it can be a more formalized system of the carbon credits system. Recently, we also joined a joint industry project together with DNV and SINTEF, and that's looking into how seaweed can be used as a natural carbon capture mechanism, and potentially, after you've grown it, it can be deposited back down in the oil reservoirs as a permanent carbon capture solution. So a number of exciting initiatives going on in relation to seaweed and also on offshore wind. We, in the family of companies that we're part of, Aker Offshore Wind is one of them. And of course, as they are developing a relatively new industry, it's important to make sure that this is done in the most sustainable way. Where do you put the wind installations? How can you mitigate negative effects on the seafloor and on marine life? What can you do with the materials that are used in the installations? And how can you make sure that you're making the most of the entire area where these installations are being implemented? So through a number of both workshops and meetings with key suppliers to the wind platforms, but also establishing a dedicated sustainability strategy within the Aker Offshore Wind. This is now being progressed immensely. And of course, we are in the midst of the decade of ocean science. So for us, being a major contributor to the IOC, and the decade itself is really, really important, and we're supporting it in a number of different ways, both through direct funding to the decade, to IOC. We're supporting dedicated programs within the decade, such as Marine Life 2030, the Challenger 150, and Earth Biogenome projects. So Alex and Eva are key parts of that. And then we're working together with other high-level stakeholders through the Alliance of the Decade and the Foundations Dialogue to make sure that more financing is being channeled into important scientific projects in this decade. So that was what I wanted to share with you today. I also wanted to leave time for questions and a bit of discussion. The floor is open. And maybe Alex, while people are giving it some thought, you can also say a few words about our scientific selection process, and I'm sure that would be possibly of interest if you would like to come on board the REV Ocean vessel sometime in the future.
Yeah, thanks, Nina. So, as Nina said, the REV Ocean vessel will be made available to the science community globally. And what this means is that we'll essentially have a long-term view of where the vessel will be sent. And periodically we'll put out a call for proposals. Those proposals will be competitive, so we will make a judgment as to the best projects and the ones which have the best fit to the REV Ocean mission, so focusing on plastics, overfishing and fisheries impacts, and climate change and its impacts as well. We also have an evaluation committee that help us selecting those projects. If your project is selected, essentially the vessel will be provided for free, effectively. What we won't cover is the kind of post-cruise scientific workup of projects and so on, but the expensive part, the ship, is provided along with the submersible and other facilities on board. As Nina's explained, this is a fully equipped oceanographic research vessel. It can map the seafloor down to 8,000 meters, has full range of equipment for physical oceanographic sampling, fisheries acoustics, of course with the submersible and ROV, we can work on benthic environments, and also certainly in the current configuration of the vessel we have this capability of sampling the pelagic ecosystem as well. The trawl system on the vessel is fitted with a unique suction system, which means that instead of pulling the net on board and picking out lots of dead and rather mangled animals, as some of you may have done in the past. We actually suck the animals from the net as it's still in the water. And those animals are pumped on board directly into aquaria in the wet fish room. So we think this is going to be a really unique facility for studying certainly the mesopelagic environment in the oceans. The submersible, just to say a bit about the science skid on the submarine. The sub can dive to about 2,000 meters. The science skid is equipped with a suction sampler or a slurp gun, as some of you may know it. A range of coring tubes, including cores specially developed for unconsolidated sediment, so the type of sediment you might find on a deep water coral reef, for example. We also have coral scissors for sampling corals with the manipulator, and the usual bio boxes and so on, and water samplers, Niskin bottles on the submersible as well. So that's the setup we have at present. Once the vessel is operating, the website will be the route of access for those calls for proposals. We are hoping to bring the submersible to this part of the Mediterranean in early July for essentially trials to figure out how to operate the submarine best off the platform that we may have available for it. But there may be scope for doing some science in this region while we're doing those trials dives as well. And Eva and I can act as contacts for that should anyone be interested. So that's it.
Excellent.
Yeah.
Thank you. Okay, so I think there was a question in the back.
Are you considering to add an AUV in the future as part of the equipment? Because mapping the deep environment, so it's a vessel that is meant to go to explore different environments, but the mapping utilities is just a full-mounted multi-beam echo sounder, so that the resolution that you're missing part of the spatial resolution, and then you want to explore it with an ROV. So we faced this problem in the past, and now we're using multi-beam from the vessels and ROVs, and now in our research project we are asking for AUV kind, because we need to fit that special mapping resolution that cannot be covered with both of the two.
Yeah, there's a plan to, I forgot to mention this, there's a plan to buy a Huygens AUV, which is capable of diving to 6,000 meters.
6,000.
And actually, Schellinger Rocker himself has become very interested in these automated ways of gathering scientific data. So we're currently looking at autonomous surface vehicles as well as AUVs to operate almost a flotilla of these vehicles from the ship. So the idea is to really use the REV Ocean vessel as a mothership. Almost, I like to think of it as a scientific aircraft carrier, to then deploy a whole range of autonomous vehicles. Those could be for seafloor mapping, for biological acoustics, for a whole range of scientific data gathering operations, which can be undertaken remotely from these vehicles. What we're also looking at, though, is a way to revolutionise the way that those data are processed, both on those platforms and on the ship. So the idea is to have a virtual cloud operating on the vessel, which will give us the opportunity to undertake quite a lot of data processing on the ship, and then beam those data in real time or near real time back to land. So we really want to kind of, I guess, take the next step in terms of data processing and linking the operations of a research vessel back to the Ocean Data Platform, our data hub, which we're developing in Norway as part of the Ocean Hub project.
Cool. Yeah, and of course, one of the requirements that we will have for scientists coming on board the vessel is, of course, that the research projects are linked to one of the 3 priority areas that we have, that it's solutions focused. We don't want to just gather data for the sake of it. It has to be linked to a proper solution, and that data is shared openly. So, of course, we will allow for some grace time to publish your results and so forth, but the data has to be shared openly so that it can be put to bigger use. And we do also encourage multidisciplinary research, collaboration across institutions, and we are also looking into developing a capacity building program and mentorship program to really enable young unestablished scientists from all over the world to be able to come on board the vessel and work with some of the best and the brightest, but also to have the support system to enable publication and future work in the scientific community. Other questions? Yes.
You probably mentioned, but what is the plan for the ship to be useful, working?
So this is the million-dollar question that we are all eagerly awaiting the answer to. I don't have an answer, unfortunately. It's quite a complicated process at the moment. Some of my team here are heavily involved in the build process, and it's been quite a frustrating period, to be honest. The best estimate is that it will be ready 2 to 3 years from today.
You are going to receive the different projects, are you going to try to combine different projects together? Because 50 places is huge groups. Or
Yeah.
you expect a project that covers the complete ship?
Yeah, absolutely. I mean, before the vessel was delayed, we did put out a call. Well, we actually invited calls as a first trial to figure out how to do this. And I think we received close to 100 proposals. And what we did there in terms of our forward planning was combine appropriate projects. So, for example, you might have a benthic project, but which was coupled with somebody working on surface ocean processes, because we could divide the time in a nice way between those 2 operations. So it certainly would be the intention to have these kind of multidisciplinary cruises, possibly operating. I think we had up to 3 or 4 projects on a single cruise leg, but essentially to make sure all those science berths are full all the time, to do as much science as possible on any particular leg of the ship's operations.
Do you have a particular geographical ambition?
No, we don't. The nice thing is that this vessel, as you saw, does have a polar class. So we can operate almost anywhere in the world. We can't operate in really thick ice, but certainly in polar regions. So what we would probably do is plan the ship's kind of journey in outline out to 2 or 3 years, and then put the calls out for proposals for a specific geographic area. What we want to avoid is people putting in proposals that would never get funded because we're not going to a particular place in that time window. So to make sure that scientists aren't wasting time, we thought it best to kind of plan future itinerary in terms of the rough geographic area of operation, and then people can put in proposals for that area.
But we want to cover as much ocean as possible, obviously, and also go to areas that other research vessels maybe wouldn't go to. Our owner is also, I wouldn't say a fan of risky projects, but he's willing to take on projects that others wouldn't because they think that it has a too high risk, for example. He thinks that high risk, high reward. So he's willing to take on more challenging projects than maybe other research vessels would take on. So that's, of course, an added bonus. But yeah, we want to make sure that we're planning well in advance so that we're using all of the available space on board the vessel, all of the equipment, and covering as much ocean as possible.
And also, we didn't mention it maybe because I always think it's such a big vessel that she will be able to operate in shallow water as well. I mean, not the vessel itself, but it has a huge amount of small boats that can take divers and has a diving area with all the diving equipment. So it will also be able to operate, to have people operating, working in shallow waters as well.
There are, of course, a number of other features that we haven't spoken about in relation to the vessel. For example, we have a huge art program on board. So we have more than 180 pieces of art dedicated to its particular place on the ocean, on the vessel, and all linked to one of our priority areas. These are either pieces that have been handpicked by the artists that were and were already made, or specifically ordered from the artist for a dedicated space on board the vessel. And it's everything from graffiti art to porcelain to ropes and music and video installations and all sorts of things, to also spark conversations amongst the participants on board the vessel and generate a broader interest into the ocean. Sorry, you had a question?
No, some question is related with the possibility to maintain alive animals on board after to be collected by ROVs or submarine or...
Yeah, there's a wet fish area with aquaria which have flow through via the vacuum system for keeping animals alive, so we can do that. So,
to bring to the land.
yeah, yeah, and also on board, I mean, we have sort of dedicated areas for, say, molecular biology, chemistry studies, geology, and so on. But yeah, the wet fish room on the vessel is probably the biggest lab space on the ship. And, you know, I think that this trawl system, that's probably going to be a unique facility in terms of research vessels globally.
And Øystein, maybe you can also say a couple words about stability and noise, or rather lack of noise.
Yeah, of course, since it has a full outfit of scientific ecosounds, both for biology or for seabed mapping, having a quiet vessel without bubbles is really important. So the ship is built to DLV silent class with particularly silent propellers and machinery, and all the multi-beams are fitted on a gondola, which put the transducers well below the keel of the vessel to avoid turbulence and bubbles. And it has 2 drop keels which extend 3 meters below the keel with all the fisheries acoustics. So it's also a really good platform for all types of acoustics.
Yes.
All the scientific equipment of the ship is managed by qualified technicians for the scientific teams on different projects. Will have to supply their own technicians for some equipment.
No, all the major equipment will be supported by REV Ocean. But obviously, if scientists are bringing on board special equipment, whether that's laboratory equipment or things to throw over the side, then obviously those scientific teams would need to support that equipment. But the equipment we have on board will be maintained and operating as well.
And we also have a large container deck, and the intention at least is for scientists to be able to bring on board dedicated equipment for very specialized type of research should we not have the available equipment on board. Even though I do think that we're fairly well covered in terms of what we already have, there will be that opportunity, of course, as well. And everything will be constantly adapted and adjusted as new scientific equipment becomes available. This is, of course, something that we will explore bringing on board the vessel to make sure that we have every opportunity available to us at all time. And the ship is, of course, built in a way and will be operated in a way that minimizes our environmental footprint. So Tamara is focusing on the sustainability side of the ship in particular. So looking at all aspects from propulsion, fuel use and consumption, energy use on board the vessel, anything from wind energy to solar panels on various surfaces of the ship, waste, eliminating waste as much as possible, handling all types of wastewater, the food that is being served on board. We even at one point explored if we could have on board hydroponics so that we could grow our own food. I think that's been cancelled at this stage. Just adds too much complexity. But we're trying to really think about everything, down to the sunscreen that the guests will be using on board. So there's, of course, a lot of different aspects that if you want to be fully sustainable, it's quite complicated. But I think a vessel like ours really have to push the boundaries in terms of sustainability. And of course we have also, because it is a super yacht, we have the opportunity to reach out to quite an important audience and influence them in becoming more sustainable as well. So by having a platform that has implemented all of these different solutions and we can showcase it, and with an owner like ours who is a billionaire, it's easier for a billionaire to speak to a billionaire than a regular scientist or a conservationist, probably. So that's, of course, a really great and added bonus of this undertaking. Yes?
Yeah, I guess there will be a database with all the data from all the surveys will be archived, and then after a period of grace to exploit the results by the scientific team that supported that requested that through, then will be available to the rest of the scientific community?
Yes, that's correct. And we've actually...
you could surf the web and see navigation tracks where they have been and all that sort of stuff.
Yeah, Alex?
Yeah, we have a data policy on the vessel, which will be to any data we can release immediately will be released immediately. So that would be all the underway data, things like Veribox data, net data, and so on. Then for all other data, we have a policy of public release as soon as feasible. We are currently looking at a general expectation to release data within 12 months of a cruise. In exceptional circumstances where there are particular sensitivities around data, might be because it's forming part of someone's PhD thesis or something like that, then we might extend that to 24 months. But we might actually look at that policy again and actually move back to a release as quickly as feasible situation. So that's the situation at the moment, the way we're thinking about it. But if anything, we might actually shorten the period before those data are automatically released.
So we've, on data, we've also launched what we call the Ocean Data Platform. And it's a collaboration with the World Economic Forum, the Aker Group, and Microsoft. And basically what we want to do is to develop the ocean version of Microsoft's planetary computer. And through collaboration with NOAA, Esri, and a couple of others, we've so far uploaded more than 200 data from 220,000 research cruises since the late 1800s. And the goal is to, within this year or next year, to have uploaded all the available open ocean data available today in one place. So it doesn't mean that we will own the data, it's just combining all the different data sets that already exists out there. And using advanced computing systems to put the data, or combining the data in new and meaningful ways so that you can have more proper analysis, better understanding of the different processes going on in the ocean, and of course, enabling decision makers to make much better decisions. And all of the data that will be generated on board REV Ocean will of course also be linked up to the Ocean Data platform. And a project that we're working on together with them at the moment will also be exploring how to ease or better facilitate data sharing from research vessels from all over the world. Because today it's, I guess, quite an outdated system where you bring really heavy disks the data that you've collected off the vessel, but we're, as Alex said, looking into better ways of directly sharing it into the cloud, for example. Yes?
Thank you for this amazing presentation, and I think we all wanted to be in your vessel soon. I was just wondering if you're thinking to collect some basic information to, anywhere where you go, so to have a basic baseline data that you collect, that maybe in 10 years' time you can have a pretty good sample of the ocean for some basic variables. Have you think about that?
Yes, absolutely. Alex?
Yeah, so the vessel will have a ferry box system on board, so it'll be collecting basic physical oceanographic parameters. There's also all the net data will also be collected. We've got to think a bit more about continuous collection of biological information. So we may look at things like eDNA, for example, as a means of sampling biodiversity more or less continuously as we progress through the ocean. Obviously, acoustic data is another data set we can collect more or less continuously, and will contribute to seabed 2030 when the ship's in operation. So yeah, I mean, essentially, our intention is to collect as much as possible, continuously as possible with the vessel, and to make that available as quickly as possible.
And we also want to make sure to collaborate as best possible with other research vessels out there, so that we're not necessarily duplicating or not operating the vessels in the most efficient way. So making sure that we can amplify the work that all the different research vessels are doing, if possible. Making sure that, if needed, more vessel time can be offered in a particular area to make sure that everything is being covered well, for example, or that the priorities that we're setting are well aligned with that of other scientific institutions and research vessels, and also aligned with the IOC Decade for Ocean Science. Okay. More questions? Yes?
How we are going to learn about the July test of the submersible? So you can propose driving sites or
Well, you obviously have an insider on our team,
Yes.
Eva, so maybe she can work some magic for you. But
to Eva? Yeah, the question or
that's probably the easiest. But of course, we will be sharing information also in our social media channels and on the web page when we've made the final arrangements. But yeah, do reach out to Eva or Alex if you have a particular request or suggestion. Given that it will be in this part of the world, it's quite a unique opportunity, of course. So if some of the scientific research that you're doing could be combined with the testing regime that we have planned for the sub, then that would be perfect.
The submersible is built here in San Cugat.
Yeah. Here we are, polishing it right now.
Yes.
You mentioned it's an NGO, right?
It's not an NGO, it's a not-for-profit company.
And where do you get the funding? Is it mostly from the owner?
Only from the owner, yes.
So he's like Elon Musk of the ocean.
Pretty much. Yeah, so he's covering all the expenses connected with the build and all of the scientific equipment. He will also be covering the operational cost of the vessel when we are in operation. And as I said, the intention is to operate the vessel also in charter mode, where we rent the vessel out to high-end individuals, celebrities from all over the world, and hopefully that will cover part of the operational cost. Should we end up in a situation when Sarah's done a brilliant job and we have so much enthusiasm from the philanthropic community all over the world, that we make a profit, that we end up in a surplus, this money will not go back to our owner, but it will be fueled into new scientific research, new projects, new scientific equipment, to particular ocean solutions that needs to be scaled up, maybe through a dedicated ocean solutions fund, for example, or a capacity building fund, things like that, to really further fuel the advances of ocean science. Okay. Should you have additional questions after this, of course, send them to Eva or to any one of us through social media, and we'll be happy to respond. And hopefully, we'll be able to collaborate with you in the future. Thank you.
Thanks.